Hi, everybody. My name is Jove. Today, we'll be talking about how we can automate batch and streaming analytics with Ascend and Imply. A little bit about myself. My name is Jove Kuang. I have been working with data for a little bit more than 15 years now. I've also worked at Ascend from 2017 to 2020. I'm currently at Imply Data. Imply Data is the creator of Apache Druid, and we're the provider of the fast OLAP database for modern analytic applications. We're also the technical partner with Ascend with a joint customer base. About today's agenda, we'll do a quick introduction, which we just did, and we'll also talk about the challenge with batch and streaming analytics we have observed as we work with customers. And we'll also talk about the solution we put together with a joint solution with Imply and Ascend. And lastly, we'll be doing a demo at the end with a Q&A session as well. So let's talk a little bit about the challenge first. As companies are adopting Kafka as their streaming bus, a lot of subsequent question comes up. Okay, now I have the data in Kafka. Great, they're streaming, they're really fast. But the big question has always been, how do I now utilize the data? How do I now make value of this data in my streaming bus in Kafka? How to query and visualize Kafka data as a database with sub-second latencies and sub-second performance is a big question. And here, as we get into it, one of the potential answers is KSQL. However, with KSQL, one can only query what's in the Kafka topic that has not been expired. What about for data that has expired? What about the historical batch data that are for the same data source, but it has already been expired in the Kafka topic? So the sub-second latency comes in when we load the Kafka data into another database. Usually that loading is going to take time. For example, one can do Kafka to Kafka connect into S3 or some object store. However, that process is always going to take at least a few minutes and create a lot of small files. So which is why we're going to be talking about how we support querying and visualizing Kafka data with sub-second latency, and as well as sub-second performance for the query as the first challenge we have come into seeing what people need in the industry. Number two, we already talked a little bit about this just now. How do people query historical batch data in the same UI and ideally even in the same table, right? So what's best for the customer and users, we find a lot of times is people would just prefer to have one table. And ideally, this table will have batch data from 5 years ago and up to data from just like a few seconds ago from Kafka. So how does technology we have today make available such a table that combines streaming and batch in the transparent way to the user, right? It's also a big challenge we have seen. Next, we have also seen a lot of challenges with joining Kafka data with batch dimension data. That changes often. So there are a lot of streaming processor one could potentially adopt. As for example, Flink or even KSQL does some of the join now as well, that they could join the stream with a table or even stream joins. But the challenge is always like, what if the data set on the right side change? Like just imagine a very simple case. We're joining with a customer data set and customer change address, right? So what if we want to backfill all the data with the new address, right? So for any pre-processing, this won't work anymore because it doesn't go back, right? So that's also another really big challenge we have seen in the space. Lastly, I mean, we have talked a lot about Kafka already and KSQL and whatnot, but what about Kinesis? What about Azure Event Hub? What about Google PubSub? There's still a lot of other like streaming technologies out there. So how do we do all of the above and make it a little bit more streaming bus agnostic so that doesn't matter which streaming bus the company has adopted, it can always work with the can always tackle these challenges we talked about just now, right? And lastly, it's great that we can query and visualize, but how do we enable our customers and companies to build modern analytic applications that delivers both batch and streaming data without doing any lines of code? That's also a really big challenge we have seen, and that's what Imply and Ascend have built products and integrations together to tackle these challenges. So first, we want to talk about a particular architecture when it comes to the solutioning space. So in this architecture, Ascend is joining Kafka streams, streaming data with arbitrary batch and streaming data sources and time window optimized micro batches. So as you know, Ascend is a very powerful engine powered by Spark and other engines now. So Ascend could be doing all the transformations in a fully automated way. So as long as anything changes, that triggers all the subsequent changes downstream automatically without any code or without any scheduled jobs. Back in the days, we always talk about cron jobs. So Ascend greatly alleviated that burden on the DevOps engineers and the data engineer to create all those DevOps processes. And Ascend can also here apply transformations of any complexity on data from anywhere, right? And lastly, as the data is being prepped, Ascend can send the data straight into Imply. Imply Jove is a database where it could be Ascend sync, which we'll show you guys in the demo in a little bit, so that we make sure Ascend makes sure the data in Imply is always up to date, right? As long as any changes from upstream is detected, it's always propagated entirely all the way down into Imply. On the other hand, the Imply Jove database supports sub-second interactive queries at any scale and high concurrencies at the lowest cost. That's the main benefit of Jove as a database. And Imply Pivot Visualization is a white label ready modern analytic application that can be put on top of the database to enable a very local, no-code way of releasing the modern analytic applications to the data consumer with a very short turnaround time. We'll show all of this in the demo in a little bit. Next, we want to talk about an alternative architecture. So in this version, Ascend is still doing the same thing, joining all the batch data sources in the time window optimized micro batches. What's different is Imply directly connects to the Kafka topics. And with Imply directly connecting to the Kafka topic, Imply Jove database can support sub-second latency, sub-second Kafka lag. What that means is within 1 second of a data point showing up in the Kafka topic, it will show up in the dashboard and Imply Pivot within less than 1 second. So that may seem too good to be true, but we'll also demo this part in a little bit. There's some potential challenge with this as well, which is because if sub-second Kafka lag is the goal, then there's really not a ton of transformation and joins and complex logic that could be applied to the Kafka stream before it's been shown, right? As we mentioned in the previous architecture, arbitrary transformations such as joining Kafka with batch data, joining two Kafka topics, any complexity of any logic of any complexity can be performed within Ascend, right? However, in this model, data consumer can get access to data a lot sooner. However, and potentially in a more simpler form, right? Because the only transformation we could do is in place Kafka stream transformation. So for example, changing the quantity by adding 1, for example, as a very simple transformation. Or we could also do what we call a lookup join. With a lookup join, we could translate things like from the customer ID to customer name, and then bring in the customer ages, customer ethnicity, for example. That's also possible. But the right join in this scenario just cannot be also a fact table or another topic, Kafka topic in this setup. So we'll demo this as well in the next section. So next, we're gonna go straight into the demo. Let me exit out of here. So to start, let me start from Imply Pivot. So what we're looking at right now is Imply Pivot. It's a purpose-built visualization layer sitting on top of Imply Druid database. So there are a lot of dashboard and tools on the market. So let me just focus on a few things that's unique. Number one, we see the numbers changes as we speak because there's a Kafka topic feeding live data in as we speak. The numbers just change again because imagine we have this online store. Customers from around the world are buying products from our online properties as well as our physical properties by the minute. So which is why this number changes as we capture those data in our Kafka topic. And number two, this visualization experience is highly scalable. For example, from the past hour, we have 340,000 records already. If I were to zoom this out to the past 5 years, all the way back to 2017, we have well over 4 billion rows in this particular table. So going back to one of the challenges we mentioned earlier, we're combining both batch and streaming in one table that's transparent to the data consumer. So that as a data consumer, I don't need to worry about like, am I interacting with a real-time system that only has the real-time data up to the current week? Or am I interacting with a batch system that has all the data, up to the past 5 years? Because a lot of times what I really want to do is compare my sales data from the current week to perhaps last quarter, this particular week as well, just to see if there's any changes, for example. In a system like this, that's something I can do. Next, now we have all these raw data. Imply Pivot also offers a very fluid experience for customers to not only find out what's happening, but also why something is happening. So for example, I just selected US. Very quickly, I could see my top seller in the US as this particular Canon cup here. The natural question I have is, why is this the top seller? So in order to understand that better, I could come into here and look at the sales volume, not just for the past hour, but also for the past 30 days. So now some interesting pattern shows. I could see that there's a really big spike in terms of the sales volume on every single weekend. So again, naturally, I would like to ask what caused the spike. We even have a one-click explain button that will send a query, that will send a group by query on a bunch of dimensions to automatically help users understand what might be contributing to the particular spike. Oh, I think actually I did need to delete a couple dimensions here. Sorry, I just had a misconfiguration here, so this is not showing, but let me take it back here, and Now let me go back here and select these two spikes and try to understand why it's selling the best. So as we can see in just a few seconds, and again, remember there are 4 billion rows in this particular table we're analyzing. We could see every single weekend, one particular customer is buying the same product from this one particular store. So again, that begs the question, is this a potential scam? Is the store selling the product at a loss? All of those we can continue to dig in with a slice and dice experience. But I think we deliver the point here. So now let me come back here. Now what's very unique is, as we talk about, if we connect Imply to the Kafka topic directly, there's only a limited amount of joins we can do. So let's look at that particular area. So this is the same store sales data set. However, I bring in some customer information in this version. So here I could see more customer information such as customer's age, customer's cities, customer's name, customer's gender, and language. And why don't we start from the language? So it seems that a lot of our customers, at least from the past day, are Kannada language speaking in this, according to this particular data set. So now let me kind of go behind the scenes to take a look at how this is set up. So as we're creating a data cube in Imply, we're basically creating a data cube using a select query. And this is the query where we do the join. So we're joining store sales with demographics regular, where demographics regular is actually a data sync coming from Ascend, which we'll show you guys in a little bit. So with a data cube being put together by a join, now all the data coming in from the store sales Kafka topic, as well as our real-time database, real-time table that contains 4 billion rows, is being joined with this Ascend data sync in real time at query time. So imagine, going back to the scenario I mentioned earlier, if my customer has a new address or speak a new language, move to a new city, resulting in a change in the demographics regular, Ascend is going to be able to pick up that change, propagate all the way down into Imply, and that join is happening at query time. So what that means is, for someone looking at data in store sales all the way back in 2017, they could potentially look at the newly updated information as well from this dimension table. That's where the power is by combining the two solutions. And with that, let me lastly close with the Ascend datasets. So in here, we see the demographic regular as a data sync at the end of the data flow here. So this is a Druid data connection that connects directly into our demo system. And from here, Ascend is monitoring this particular Druid data source demographic regulars in our system, so that for any changes upstream, Ascend is going to be able to automatically update this demographics. And then as a result, the data consumer sitting on the other side of this dashboard, they can always get access to the latest data. That concludes my demo today. Thank you very much for attending my session. Now we're going to get into a Q&A session.